Alright, how's everyone doing? Today we're going to do problem 1.1 in Griffith's Quantum Mechanics 3rd edition. And for this, we're going to be computing the expectation values and essentially proving equation 1.12, which is the standard deviation is equal to the expectation value squared minus the expectation value quantity squared. So we're going to be proving this in part C, but for part A, we first need to compute the expectation value squared and the expectation value quantity squared. And in this case, we're doing it for the distribution of ages. So the j's are the ages. And we're first going to calculate this quantity because it's, I think, easier. We already have the formula here. Expectation value of j is equal to this. And each j is the age, and n of j is the number of people with that age in the distribution. And I have the distribution over here to the left. We see that for age 14, there's one person. So the first term in the sum is going to be the age, which is 14, times the amount of people, which is one person, plus the next age, which is 15, times one person, plus 16 people, plus 22 times two people, plus 24 times two people, plus 25 times 5 people, divided by n, which is the total number of people, which in this case is 14. And when you do this math, all you get is 21, but we're looking for the expectation value of j quantity squared, so to do that, we just have to square both sides, and we get 441, and that's the first piece for part A. And then the next piece we need is the expectation value of the age squared. So we just rewrite the formula and we get the sum of j squared instead of just j times n sub j all over the total number of people. Now let's just write this out. We get 14 squared times 1 plus 15 squared times 1 plus 16 squared times 3 plus 22 squared times 2 plus 24 squared times 2 plus 25 squared times 5 all over 14. So this is the expectation value of the age squared, and this yields 460. So that's part A done. Now for part B, determine delta j for each j and use equation 1.11 to compute the standard deviation. So delta j for each j. Delta j is actually given by equation 1.10 in Griffiths, but it's basically just the difference between the age and the average age for each age. So for delta 14, which is the first age, it's just 14 minus delta j, which is 21. So that's equal to negative 7. And then delta 15 is equal to 15 minus 21, which is negative 6. Delta 16 is equal to 16 minus 21, which is negative 5. And delta 22 minus 21, which is 1. Delta 24, I believe is next. 24 is equal to 24 minus 21, which is equal to 3. And finally, delta 25 is equal to 25 minus 21, which is equal to 4. And so we now have each delta j, and we want to use equation 1.11 to compute the standard deviation. Equation 1.11 is this equation, expectation value of the uncertainty in j squared. So we have all the delta j's, so now we just need to square them. So the formula for this is the same as the previous formulas. It's just the sum over delta j squared times n sub j all over the total number of people. So this is going to be equal to the first delta j squared, which is going to be equal to 49, 7 squared, times 1, there's one person, plus 6 squared, which is 36 times 1, plus 5 squared, which is 25 times, there's 3 people for that, plus 1 squared times 2 people, plus, that's just 1, plus 9 times 2 people, plus 16 times 5 people, all divided by the total number of people, which is 14. So when you do this, you get roughly 19, okay? So that's the standard deviation squared that it asks us to calculate for part B. And now for part C, we're going to use our results in part A and part B to check equation 1.12. And what is that? Equation 1.12 is the standard deviation is equal to the square root of the expectation value squared of j minus the expectation value of j quantity squared. So let's just calculate this. We found in part A that the expectation value of j squared is equal to 460. So we've got 460 minus the expectation value of j quantity squared, which is 441. And this is all under a square root. And so this is equal to the square root of 19. And now we can see that comparing this to part B, if we just square both sides, we get the standard deviation squared is equal to 19, which tells us that the results are the same, and we've now shown the standard deviation squared. And that's the end of the problem.